Ladies and gentlemen, hello and welcome back once again to another episode of The Briefing Room. My name is Eric Cavanaugh. I will be your moderator for today's event, Stay Flexible, 5 Ways to Harness Information Assets. So we're going to have an interesting conversation today. There's a slide about yours truly and enough about me. The mission, as many of you know, in The Briefing Room is to reveal the essential characteristics of enterprise software. So we take a bit of a different approach from most webcasts where we cover a different topic every month. We invite vendors to participate. Then when they do, we invite an analyst. And the analyst and vendor do not collaborate before the show, which is remarkably different from just about every other webcast you'll find. And the reason we do it that way is because we want to preserve the organic style of discussion that you get from a traditional analyst briefing. So the only difference with our show compared to an analyst briefing is that we do it before a live studio audience. So the idea is we want you to be able to learn as if you're peering over the shoulder of the analyst as he's poking around trying to understand a particular kind of technology. So kudos to all the vendors who embrace this new style of webcasting, and a big thanks to all the analysts out there who join us as well. So March is Integration Month. Obviously, there are a lot of very interesting challenges going on with integration these days. ETL, of course, is the traditional workhorse of integration, but there have been other technologies. For example, change data capture has been around for years and years and years. It seems to be making something of a resurgence these days, possibly because ETL batch windows are tightening, possibly because of the cloud and all the interesting challenges posed by integrating with the cloud, which of course relies on APIs, application program interfaces, as opposed to traditional EAI, enterprise application integration. You can see the other topics coming up. Discovery Analytics month is sold out, intelligence about halfway. Not much in governance yet, which is kind of surprising with all the talk that vendors do about governance, but we'll see who steps up to the plate there. And then again, analytics in August, because it is such a hot topic. So here's just some more information about integration and what has been happening. So the topic for today is going to focus on data virtualization. And when we talk about 5 ways to harness information assets, we're going to get into the different kinds of things you can do using virtualization. But I should point out a couple interesting things. One, we'll surely get into a discussion of performance. So years ago, data federation or enterprise integration or enterprise information integration, as it was called, was certainly useful, but it kind of got knocked for not being as performant as traditional ETL, where you just move large sums of data. But I have this sort of recurring theme that I talk about where I ask, when are we going to stop the madness with ETL? Because every time you move data from one place to another, you open the door to problems. You open the door to data quality problems. You open the door to being able to reconcile data quality or data assets, data points, I should say. And besides which, it's not cheap to move all that data around. It's very expensive, and it's costly both in terms of time and in resources. So data virtualization, one could argue, is really like the maturation of data federation, and we're going to learn all about what this stuff means today. So our analyst is a newbie here in the briefing room, Rick Vanderlands. He's an independent analyst. That's typically who we work with in the briefing room. He's been around for quite a few years and works a lot in the field. So he also speaks a lot. He's written some books, and he's calling all the way from the Netherlands. So we appreciate the fact that he's calling in from a long way away. Now, Composite software, also been around for quite some time, arguably one of the longest standing data virtualization vendors. They use this data virtualization for a number of different things to augment traditional integration type technologies. So I've been following these guys for about 7 or 8 years myself, and they've been around longer than that. So we're pleased to have them in with us today. So Bob Eve is the Executive Vice President of Marketing over at Composite, and Bob is not your average marketing guy. He actually knows the technology, so we're happy to have him step into the briefing room to tell us what they are doing over there. And Bob, I have just handed the keys to you, so take it away.
Well, great. Thank you, Eric. I'm really looking forward to our conversation today where we focus on flexibility and really bringing to bear that flexibility to both the business and IT organizations. And it's fun to join Rick on this call. Rick is a renowned expert in data virtualization, and we'll be talking about the book he's soon to publish on the topic. So I hope you'll get a really the audience today will get a really good look at data virtualization in general, and I'll do that at about a 30,000-foot view because I know some of the people on the call understand it pretty well. Others, it's a first-time introduction, so I'll kind of cover it at the high level. But then I'll focus on why would we do anything different than what we've been doing in the past. What is driving change? Why do we need to do something that might be uncomfortable at first, or might require a change in systems and methods that we work so hard to put in place? So we'll talk about why do anything different. Then I'll give some example cases around that demonstrate data virtualization's flexibility. This way, I think the people on the call today can understand how this might be used in their situation to solve their problems. And then finally, we'll get Rick to join us in the discussion. So I look forward to our conversation today. So data virtualization at a glance. If you really think about it, there's two ways to consider the concept of data virtualization. One is what it provides. To the business, it provides business views of enterprise information, so the complete, actionable, high-quality information that they need in order to make their business decisions. So it surfaces that data, and then that data can be visualized in any number of tools, whether it's Cognos, Business Objects, Excel, mashup screens, etc. So think of it first of all from the top of the diagram, which is the consumers of the information, and that they're getting insight into their customers, their orders, their risk. What data virtualization technology does as a platform, it's a middleware, and it kind of spans between the diverse sources inside the enterprise and beyond, and kind of rationalizes that information and in such a way that the consumers or the consuming applications can understand and query that data and use it to solve business problems and address business issues. One way to think about it is go under the covers a little bit, and I really want to focus on the concept of views. Now we can use the term view and data service synonymously. A view is kind of an instantiation that's more about relational, and it's just like views that everyone on this phone call understands what we're talking about, except these views are often across multiple databases, not just in a single database. And then a data service is a similar implementation with slightly different technology. But the idea is under the covers, you have views that present the data to the consumer that are ideally organized for the consuming applications. So for example, if this is some sort of web service based application, this order view might be in the form of a REST call, whereas this order view over here might be feeding through JDBC to a reporting engine. So one thing we do is we try to get the data at the top of the diagram close to the consumers in a structure and a format that's very consumable for them. Now all the data comes from the diverse sources, and we do through a set of activities and transformations and rules and views kind of bring that data together into maybe common canonicals for major objects, and then span that back out. So it almost, you can see an hourglass from the diverse sources to the canonical out to the diverse consumers. And really it's just views calling views. And from a performance point of view, this might look like there's a lot of stuff going on and everything's going to be serial and be really slow, but that really isn't how the technology works underneath it. It optimizes the whole query all the way down the tree, and whether it's 4 views along the way or 1 combined view, the optimizers figure that out and optimize that query to maximize the performance and response time. Flexibility is the theme today, and for our customers who are, for the most part, very large enterprises in pharma, energy, financial services. Lately, some manufacturers and retailers have joined, like Lowe's, for example. for them, flexibility in their large organizations and able to address a range of problems with a range of solutions is one of the things they really like about data virtualization. So, so understand that, like you, the people on the phone, flexibility is important to you. It's also important to our customers, and I think it's a big reason why they've gone with the data virtualization offerings and added that to their mix of data integration solutions. If you want to understand what some of those large enterprises and even some mid-tier enterprises are doing using data virtualization, we wrote a book about it. And in that book, we cover 10 different case studies, and we cover them in detail. So the book's about 200 pages, and 150 of those pages are these case studies at a range of companies: Comcast, the Northern Trust, New York Stock Exchange, Pfizer, Qualcomm. So well-known companies, and some we couldn't quite use their name, but you can. They're very large Fortune 50, Global 100 type companies. Again, in each case, we really drill into what business problems they were trying to solve, their technology approach, some of the other things they considered, how they actually did the implementation, what some of the critical success factors were, and where they're going in the future. Under the covers, what's behind a data virtualization server? What's inside? Really, it's pretty simple if you kind of break it down. You know, we have to do the development, the building of the views. So there's a development environment, and we have a number of capabilities in that area. And once the views are built, there's the runtime component. So the calling app, the front-end application, just say business objects report, would then goes through SQL, maybe ODBC, for example, and engages the data virtualization server, at which point the server goes down to the source, pulls the data together, uses the security, and delivers it back to the consumer. And then, of course, there's an entire management environment, as you would expect with middleware. So you have to set up the system, manage and monitor the activities, the health, et cetera, perform clustering for larger scaled outs, RAS type situations. So it's kind of the things you mostly expect from a middleware, development, runtime, and management across a diverse set of sources for a diverse set of consumers, and a lot of good, really cool technology inside. So we've talked about what data virtualization is, kind of at the 30,000 foot level. Let's talk about why we'd bother to do anything different. Eric spoke to a couple of things that were driving perhaps the change in CDC, you know, speaking to the cloud, and I see a lot of other drivers, both business and technical. Let's address that. Let's start out with this kind of the idea of what we used to use nearly exclusively. Remember when the world was a simpler place and you put all your data in the enterprise data warehouse, and if you needed flexibility, well, that was maybe a new sandbox, or maybe a dependent data mart with a specific support of a specific requirement, a support of a specific analytic tool. That was flexibility, you know, and then occasionally we might add a source or change a dimension or that sort of thing, and then just work from the enterprise data warehouse as the center of the data management universe. Then a couple things changed. And two very large things are in the process of changing and kind of shifting the whole ground underneath data management. First of all is big data. I think we're all well aware of some of the activities there. And the second is the whole cloud delivery paradigm. So having a lot of the applications resident in the cloud and utilizing infrastructure that's not within the four walls of your computer room. What does that mean to data virtualization? Well, with those two trends with the addition of mobility has really kind of made that multiple sources and multiple consumers landscape much more diverse, much more complicated, setting up all new sets of business and technology requirements that I think have just stretched what a data warehouse can do in the middle to rationalize all of that data, especially when some of it's outside the firewall, coming through some API from Salesforce. Sometimes when the one source might be one of these new big data sources that's just as big as the warehouse in terms of the size of the database. So it's not as though you're going to replicate. I mean, Eric talked about the challenges of when you put data in the second place, just the cost and all of that. But here we're talking about a huge multi-terabyte database going, what are we going to replicate that into a data warehouse up here? It doesn't make a lot of sense, and I think people are realizing that. So people are using more fit-for-purpose stores. They're data appliances. They're using cloud to solve other business problems. And then they're starting to have a consequence that says, okay, how do I integrate this data now that I've optimized a number of sources and I have diverse users all over the world using a whole range of devices? It's not as though the old way was all that great, frankly. Here's some data from TDWI and just about a research benchmark that they have. I know it's really small and difficult to read, but if you really drill into it, the first question is, how long does it take to add a new source to your data warehouse? The result is typically 8 weeks, and it's not getting any better. It's been 8.4 weeks, 7.4 weeks, 7.8 weeks. So 40 days or so before you can even add a source. Then to add a report on top of that takes another 6 weeks. And then if you want to change any hierarchy in the database, another, that could be 5 weeks. So, do you feel really good about the service that IT is providing business? Is that providing a lot of flexibility and agility when you have these kinds of numbers are the norms and have been the norms for a long time? I just question, whether we really thought the old way, whether the old way was all that fantastic. If you ask business whether it was fantastic, here's some research from Forrester. Half the times the BI stakeholders, the user of the results of BI, the business people themselves, feel that the BI applications aren't agile enough or flexible enough. They're not able to get the information to move at the speed they need to move business. So again, a bit of a challenge in the prior paradigm. So I think these are some of the drivers that are getting people to think about why they should use data virtualization. It's why the Composite customers have adopted data virtualization. And so what I want to do now is talk about some of the case studies into techniques and approaches that people are doing. So kind of bring it home in terms of whether or not data virtualization would be a good approach for the people listening today. Data virtualization provides a lot of flexibility, the architectural deployment of data virtualization itself. We've seen 5 patterns of adoption evolve. Originally, 6, 7, 8, 9 years ago, when Data Federation kind of came to be, it was really focused in enabling BI data federation, so allowing products such as Cognos capture more sources beyond their cubes, beyond maybe some of their ODBC sources. So they could also query web services, for example, or get data out of SAP. So that was oftentimes the original use case, and that's still a big use case for the adoption of data virtualization, particularly when some of those sources aren't available to the BI tool, or when performance is an issue and the BI tools aren't really optimized to do the kinds of queries that the data virtualization tools can provide. Second pattern of adoption, and this has been very broadly adopted over the last 3 or 4 years, is the idea of extending an existing data warehouse. So you've made an investment in a data warehouse already, but there's some new data source that you want to add to that, and you don't want to wait the 4 weeks or 5 weeks to change a dimension and the 8 weeks to add that data source. Or maybe it's a source you can't add because it's an external source and you need to only access it as a web service on demand. Or maybe you want to extend the warehouse with some of today's data because the warehouse is only updated as of last night. So there's a number of reasons to extend a data warehouse, and I'll talk about some use cases and how we do that. But that's a second big area of use. Third area is creating a data virtualization layer, almost an architectural concept between the diverse sources and the diverse consumers. Some people call this information as a service. It's part of an information-oriented architecture that the folks at Middleware talk about. Another way to another term Gartner uses is logical data warehouse. So think of it really as a almost conceptually like a data warehouse, except it's not physically instantiated in one place with one schema bound to that database. It's a more broad schema, logical schema, and the sources are more logically available or virtually available. Of course, big data integration, bringing the big data together with the enterprise data, that's picking up as more and more people put more and more big data appliances out there, and then as a consequence say, wow, I'd sure like to combine my analysis of that data and that big data source with, some of our traditional enterprise data. And then bringing data in and out of the cloud with the rest of the on-premise is a fifth area where people are focused. So those are big concepts for different architectures, different patterns of adoption. Why don't I drill into a couple of use cases that at one level down, I think I can more clearly communicate some of the things that people are doing. In this first case, this is an example from a mutual fund company, customer of ours. We all know that data marts can kind of proliferate. Each new problem comes along. People decide, well, it would be a lot easier if we just created our own little data mart for that, which works great, but at some point you end up with a whole bunch of extra dependent data marts, oftentimes leveraging data that's already been managed and controlled by the data warehouse. Well, what the mutual fund company found was they could use data virtualization to create virtual data marts in and around the scope of using the infrastructure of the data warehouse to hold the data, but then use the data virtualization products to make the data appear as though it's in its own virtual data mart, and then support those analytic needs in that way. Not only were they able to meet new requirements faster with this approach. It's a lot faster to stand up a virtual data mart than it is a real one, a lot less costly, but they were really able to eliminate about half their data marts that they had proliferated in the past, and that's just had a huge, huge savings and added wonderful flexibility because now they don't have to maintain all these data marts. They can actually add new data marts virtually as required and shut them down as required. So that's one case. So kind of the classic hub and dependent data mart spoke, but this case the spoke is a virtual data mart. Another thing that we've all seen is the need to prototype a new data warehouse. And if you really think about all the moving parts it takes to get a data warehouse together, the entire schema, the ETLs to get that schema supported, to support that schema, the actual migration of data, and then that's the point at which you can go, oh, did we get it done right? Did we meet the need? And how often does it really happen that you met the need on the first try? And now we're in the mode of those long TDWI cycle times that's required to bring the data closer to what the data warehouse, closer to what the business really needs. Well, what you can do with data warehouse prototyping is build the schema virtually using a data virtualization product like Composite, and then show that information to the business users immediately. They can provide immediate feedback. You could iterate that prototype and get the understanding of the data right. Really build the models, build the schema for what's going to be needed. You test driving all of the ETL per se, and you get that up and running rapidly, weeks, months kind of thing. And then you take it to the next step, which is take all that knowledge, all that domain knowledge, and just bring it over into a new data warehouse and new ETL scripts. In this case, those are already predefined. It's very clear. Sure, you have to still put the schema into the warehouse, and you still have to write the ETL scripts, but we've proven them all out. We know they're going to work, and we know the business is going to like it. So this is a technique that we're seeing used more and more frequently as a way to provide some flexibility and agility around data warehousing, particularly in the prototype case. A third case is a classic data warehouse migration challenge that many people face. There's so many great new alternatives for re-platforming older data warehouses with a lot of the new appliances. The price performance is just fantastic. Also, there's, as we all know, there's the degradation of the data warehouse over time. You know, what you set it up for originally several years ago and what you kind of optimized it to do, people liked it, and they said, well, could it do this, could it do this, could it do this, and you've added and added and added, and eventually they kind of become clunky. And I think any of the data warehouse vendors will tell you that, and the research analysts will as well. And so that you need to tune them and change them and re-platform them and rethink them. And so how do you do that, though, and without running a huge risk to the business? Well, we see companies do that using data virtualization. So you have your as-is state, and the first thing you would do is you go in and you insulate the reporting layer. So you drop the data you do a schema, virtual schema over the warehouse using data virtualization, and then re-point the reporting programs at the reporting layer, not at the data warehouse itself. So we kind of, first of all, put a layer of insulation between the reporting apps and the data warehouse. Once you've done that, you are now free to swap out the data source. So you revise the scripts to the ETL scripts to point to the new data warehouse, and you just repoint the virtual reporting layer to the new data warehouse. Much simpler, a lot lower risk, fewer moving parts, a lot easier to do this in a phased or staged fashion. You can put some logic to, you know, so if this transition from here to here is over multiple weeks or maybe over multiple, you break the domains down and half the domains are here and half of them over on the other side for a while, that's okay. We can handle that up here with some logic. So again, we've reduced risk. We've enabled the ability to get to the new data warehouse that might have new cost savings or better business benefits. Data warehouse federation. So, we have a number of large companies customers who do mergers, and what happens when you have a merger is you can have two data warehouses that were kind of both optimized for the same function, except now it's in two different companies. So for example, the research databases at two different pharmaceutical companies, or the marketing database at two different energy companies, for example. You're going to bring those together. How long does it take to migrate, to redesign and you know, rationalize across two data warehouses a common schema and then move all the data and get all that right, particularly when these were built on different dimensions and different concepts than the one in the other company? Well, what we see people do in that case is put a federated data warehouse view across both systems and do that kind of rationalization logically. So we maintain the warehouses as is, but we present them in a unified fashion to the applications above. And we've seen in one case with a pharmaceutical able to combine the information in their two research pipelines in less than a month, as opposed to you know, time measured in years. So this is a great benefit in terms of bringing the two companies together and gaining synergy. Final case here is just the concept, you know, of performance and having flexibility to scale data virtualization into high volume use cases. I just present these from a survey we did. It's talked about 8 of our large customers, and we just picked some of their cases. And what was the kind of the highest number of end users that were actually coming through data virtualization through to the data sources, how many developers were working on the data virtualization server, what were some of the query volumes, what was some of the size of the average queries, the average rows, etc. And when you look at this, you go, wow, it really can scale to a number of, you know, to a lot of use cases that are very could support a large percentage of the demands in a typical enterprise. Not everything. Certainly certain things should be, if you're going to redimension the data and perform historical analysis, you don't, those are not going to be very good use cases for data virtualization, because that redimensioning and the rolling up of all the information is not is better done in a kind of a batch process. And so you're probably already, if it's important, you're probably already doing it in a batch process with ETL and replicating that into a physical warehouse. And great, then we can query from there. And as we've shown in some of the cases before, the data warehouse can be a critical source. So that's the point on scalability. So I've really talked about 5 different flexibility use cases. Talked about warehouse migration. We talked about federation of warehouses. Talked about data warehouse prototyping. Talked about the whole idea of hub and virtual spoke. So really, in and around just the core concept of data warehousing, the traditional integration approach, we've talked. You could see a lot of flexibility that data virtualization can provide. With that, I'll end my section and turn it over to Rick. Here's a little preview of a screenshot of Rick's upcoming book. And so we've got the 2 data virtualization book guys on the phone now. So you can follow up and get more information. Rick, with that, let's turn it over to you.
Yeah, and Rick, I made you the presenter, so to go ahead and click anywhere and use the down arrow. There you go.
All right.
There you go.
Okay, good. Well, first of all, thanks, Robert, for plugging my book. I really like that. And thank you all for listening in to this. Before we do the questions and answers, and before we make it hard on Bob, Eve, what I'd first like to do is sort of talk for a few minutes on my views on data virtualization. And let me begin by saying that I agree with Robert about the fact that the world of BI is definitely changing. And if the world of BI is changing, it probably means that the way we build our BI systems, they have to be built in a more flexible way. So let me spend about a few minutes on that, and then we'll go into the questions and answers. And I've also seen a lot of questions come by from the listeners, so that's going to be fun. Now, I think for me, the biggest question, though, if the world of BI is changing, for me, the biggest question, and maybe even the most intriguing question is are our current BI systems ready for all those changes? Are they really flexible enough? And I found out that the best way to answer that question is to go back to the question, why do we invest in business intelligence? So why do we all invest in business intelligence? Now, Boris Evelson a few years ago gave a great definition of what business intelligence is, but I think you can sort of summarize it with that sentence on the second bullet. The field of business intelligence focuses on supporting and possibly improving the decision-making processes of an organization. That's why we do it. So when our users were asking for a business intelligence kind of capabilities to help them out, support and improve the decision-making process, they were definitely not asking for building databases. That was not their question. They wanted to have BI capabilities. They didn't ask for databases. They did not ask for ETL scripts. They're probably not even interested in technology whatsoever. In that respect, it's a little bit like the phones we use, right? If I use a phone, I'm not very much interested in how all the technology works, how the connections are made, whether landlines are used, or whether the connection goes via satellite or something. I don't care about the technology. Probably the same way that BI users don't really care about how the technology works. What they're probably interested in is the data that they get. Do they get it on time? Does it have the right quality level? And so on and so on. So when they were asking us to build these BI systems, they probably thought that we would build those systems straight on the databases we already had, the production databases. But as we all know, that's not really what we did. What we did in most organizations is we created these business intelligence systems, which at the heart have, well, let's call it a chain of databases. Databases such as staging areas, data warehouses, data marts, I'm probably even forgetting operational data stores, personal data stores. And then all these databases are linked together using ETL scripts or replication technology. And most importantly, what we also see is that most of the reports that we develop are tied to the databases that they were accessing. Of course, it's a very conceptual diagram that you're now seeing, but I still think it's representative for most of the BI systems we have been developing over the years. And the big question now is, are these systems ready for these changes in the BI industry? Are they flexible enough? And more the feeling I have is that the answer is not really. If you look at the changes that we see, and you can sort of group all the changes in two ways. We have the changes that are coming from the technology, which we normally refer to as the technology push. So we're talking about things such as analytical database servers, or called analytical platforms, NoSQL products, data virtualization products, the theme of this session, search technology, and the list goes on and on and on. And we all know that technology does lead to changes, right? Because new technology creates new opportunities. I just remember the steam engine and the X-ray. New technologies change things. But on the other hand, you also have the business pool. All these new forms of BI. Robert already mentioned Agile BI. I believe you also mentioned self-service BI, operational BI. We're getting all those new forms. And the question I have more and more, will we be able to build that on these BI systems with these classic architectures? And for me, classic architecture is one where you're based on a chain of databases. My feeling is more and more that if you want to have real agility, real flexibility, we probably have to bring in data virtualization technology. Or let's put it differently. If you look at the diagram that you have in front of you, if you look at all the components that make up a BI system or a BI architecture, you can sort of divide all these components into two groups, or call it two layers. You have the reporting layer, of course, where you have all the reporting and the analytical capabilities, and then you have the storage layer with all the databases and the ETL stuff. Now, if you would bring in data virtualization technology, I think what you can say is that what self-service BI has done the last couple of years, and we probably all know all these tools, right? These very flexible, agile reporting tools, self-service BI, and what those tools have done for the reporting layer, to me it looks as if data virtualization is going to do that for the storage layer, making that layer also flexible and agile. And I think this is an important point. But now the big question, of course, is are the products, the data virtualization products, ready? So let's see if that's true. And we're going to do that, of course, with Robert. Being from Composite software, he should be able to answer all our questions on this. Robert, are you ready for the questions?
Yeah, absolutely. Let's go. I'm in the middle of trying to tweet something, but I'll put the tweet down and give 100% of my attention to you, Rick.
All right, good.
Let's go.
Now, now let me pass a question on to you that I normally get when I do presentations, seminars on data virtualization. It's always the first question that I get, and it is, it's on performance. So if you add an extra layer in between your reporting environment and your databases, doesn't it make it slower? That's probably question number one I normally get. How do you respond?
Yeah, it's kind of interesting. And even Eric spoke to this at the start. People I think have these older perceptions about performance when it comes to data virtualization. And I kind of usually speak to that in a couple different ways. One, I show that slide that was nearly the end of my deck that shows just what real people are doing. The other thing is I encourage people to think about, okay, so when did you get this idea originally? Was that before data warehouse appliances? Was that before networks have quintupled in their speed? Was that before, companies like Composite have put 300 man-years into query performance algorithms and created all kinds of flexibility and caching techniques? So I think sometimes the people just kind of are concerned about something that technology has gone a long way to help solve. The other thing I kind of want to speak to is, remember, we're not necessarily solving the data warehouse historical analysis problem, which requires a redimensioning of the data and a lot of the data and a lot of transforms in advance of actually doing the queries. These are different problems. Those problems have been solved. We can then query those databases. That's great. We're not trying to use data virtualization to solve those particular problems. And I guess finally, let's put this back into the thought process of the business intelligence consumer. So which do you think the consumer would prefer? One, answer A, the traditional approach that says, in 40 days from now, I can get you that information and the query will take 2 seconds. Or would you prefer 2 days from now, I can get you that information and the query will take 40 seconds? Which do you think the business person would prefer? I think most of the time they'd say, hey, if you can get me that information tomorrow, I don't care if the query takes 40 seconds. And it's not going to be, 40 seconds relative to 2 seconds. But see the point I'm making? Let's answer performance relative to the real requirement of the user. And I think a lot of times if you consider that technology, the growth of technology and where to use ETL and data warehouses for historical data and where to use data virtualization, you'd come to the conclusion that performance isn't a big issue.
It's not? Okay. Now, there was one question that I saw come by that said, well, but if you, let's say, if you make more stuff virtual, doesn't that mean that eventually a lot of the queries will be going for one and the same database, probably the data warehouse? Doesn't that mean that if you go for data virtualization, you'll need more SQL database or relational database power there? So isn't this sort of like you need an appliance?
Well, certainly there's a lot of elements to that question. First of all, we see fantastic performance from the appliances. And we have a lot of IP at Composite where we know how to take advantage of that horsepower. So yeah, so so what you're saying is if the business wants more information and needs to query more things, should we buy some more hardware or some appropriate hardware databases to support them? Yes, absolutely, do that. And let's do that as efficiently as possible in terms of the queries we make and use the best set of technology in providing that to the business. So,
from the top of your head, would you say that most of your customers who have now your product up and running in an operational environment, are they using appliances, or would you say no, it's just very small percentage who's doing that?
I think I'd say quite a few are using appliances because I think our customers are, early on are the ones who push the envelope. So they're the ones that were trying, the people who would try data virtualization as a new approach to solve some of their problems were probably
okay.
Edge for data warehouse appliances, and that's good because they push the envelope in terms of the technology, and then the later adopters gain the benefit.
Okay. Now I know that your product supports caching, or call it materialization. There was a question from one of the listeners as well on this topic. So how advanced is caching or materialization of query results in your product? Or maybe I should rephrase that question. If I use caching in your product, doesn't that mean that, again, I get a lot of physical databases that I have to manage myself?
Well, first of all, let's just talk about the options that you get with caching and what problems you might solve. So let's talk about some problems you might solve first. So let's say one of the data sources is unavailable every night from midnight to 2 in the morning. Well, maybe we want to cache that data and make it available for the queries during that time window. That's one example. Another example might be there's certain information that's slowly changing dimension type information that might be but queried often, and we want to cache that. Maybe that's a price list or some sort of product or parts list or something of that nature. So there's a lot of reasons to use caching. We provide a great deal of flexibility on how we do it in terms of where you cache, how often that cache is refreshed, whether that's refreshed in total or incrementally, kind of like a CDC approach. We can have a single cache. We can have multiple caches distributed. So a huge amount of flexibility. And that's the theme here today, flexibility. So we provide all those options to people. Every time you have to say what the destination of the cache is, and where that cache should be stored. Is it going to be stored on your Netezza appliance or on a little MySQL database? So the amount of data that you use, the amount of caching, you'll definitely need storage for that. Now, but the thing is that storage is kind of pretty consistently maintained. The data is refreshed through these controlled mechanisms. Typically, you're putting that cache close to the other data that's going to be queried, so you get a lot of performance improvements. So, it is kind of a hybrid between a pure virtual model and a full physical instantiation. And again, it gives you some flexibility in the middle. Not every problem should be 100% virtual. Not every some are. Not every problem should be solved 100% physical, but some are. And sometimes it's really nice to have the flexibility to mix and match, even down to the cache.
All right. Now, one of the reasons why we like ETL is it allows us to do all the complex data integration and data cleansing of the data. And then when it's done, it stores the result, and then we query those results. Your product is able, of course, to do all the data integration and the transformation and the cleansing live, right? On demand, in flight, whatever you want to call it. If we have complex transformations, complex data cleansing operations, would that still work in an on-demand environment?
Yeah, so it's a great question. The whole data quality issue is important, and getting consistency in the data. So the way we think about this is in several modes. First of all, I started my career as a manufacturing and just-in-time quality consultant. So, one of the first things I learned was the more inventory, in other words, the more times you replicate data, the worse the quality is going to be. So that that definitely applies to data as it does inventories in factories. So one of the things one of the gains we get from data virtualization is we avoid a lot of that replication, and that just automatically improves quality in and of itself. Now, when it comes to the specifics of what kinds of transformations should be done in flight versus can be done in flight versus what's better to be done in a batch process, well, there's certainly a number of consistencies and validations and transformations that are just as easily done during the query as they are done and substantiated. But complex processes that might involve a human interaction, something that has a lot of matching and deduping, where you have to have multiple scans of the database, those are best done as batch processes, and absolutely. And then you want to definitely post the results. You want to persist the results. And then we can query that persisted result. So I think those complex transformations, whether you use ETL or other workflow engine to clean the data and deal with those business decisions, those are definitely very important and quite useful for a certain subset of data quality issues.
Okay. Now, let's make a side step here and that if you look at data virtualization technology in general, you have very advanced technology inside your product. But if you look at reporting tools as business objects and ClickView, they also claim to have data virtualization technology. Maybe they don't call it that, but they also say, well, we can join data from multiple sources, we can transform it. Does it mean that if I use their product on top of your product, I have two data virtualization products, or do you see a difference between the two?
Well, let's talk about a couple areas where they're different and then how they might work together. So typically in those, if you remember some of our earlier diagrams, it was kind of many sources on the bottom and many different consumers on the top. If you'd ask those companies to describe the model, they'd say, well, there's certainly many sources at the bottom, but there's one consumer at top, which is us, business objects, for example. So I think we're more engineered for a many-to-many kind of solution. And, name a big enterprise that doesn't have more than one reporting approach. So that's one difference. The other is we've really optimized for query performance, and I think they're optimizing for their business, their reporting and their visualization aspects. So people are probably aware for a number of years Composite was OEM'd by IBM or by Cognos, and then now is embedded in some of the virtual view manager capability. But a lot of that, a lot of times we would get called into accounts when additional performance was needed, and so we would take the approach, the way the queries worked in the Federation capabilities built in those tools wasn't quite as optimized as what we could provide, and then certainly don't have the caching options and some things I just described. Okay. So what we see people doing is they using their metadata layers and their reporting tools to do more reporting visualization type rules and that sort of thing, and having more of the data transformation and management rules in our layer. That's what we see in actual instantiation.
All right, that's clear. Do you think they're going to extend their data virtualization capabilities, or in other words, are you going to get competition from those products in the coming years, you think?
I imagine. I mean, I think you and I would both agree that data virtualization is a good idea, and yes. Therefore, and it's a trend that's accelerating. So why would they not continue to extend their products the way they also have extended reporting products to also do analytics, for example? So I would anticipate that over time they will extend their offerings in these areas. Sure.
Okay. Let's see. Is it about time that we should give the word back to Eric?
Yeah, I guess it's about time. We have a lot of great questions in here, so let's just go ahead and dive right in. And Bob, you've been answering some of them, at least in part as we've gone through, but let me just start diving in. I'll just scroll to the top here because we've got a whole bunch. Okay, so fairly simple question, but I think it's a valid one. And again, you talked about this, but one of the attendees asks, is the data for these views kept on the Composite server, or is the data pulled when the view is accessed? And I guess the answer is both, right?
Well, we keep the metadata, and then we pull the data from the source on demand. Now, we might temporarily persist that in a cache as well, but that wouldn't be within our server. We would cache that on a nearby database. So really think of us as the data flows through us. It doesn't kind of reside with us for more than a few milliseconds.
Okay, and when you persist it for caching, that's kind of before where you were talking about using stuff like Netezza or Greenplum or Vertica or one of those appliances? Yeah,
there's about 7 or 8 different application or databases where we that we support as caches, and we use all the advanced bulk loading techniques that they provide in order to build those caches as fast as possible, and make them then available. And then we'll come back and query those caches along with other data sources, later.
Okay, and here's another question about performance, and I know you talked about this already, but can you kind of give some detail on how it is that you're able to avoid performance issues? What's been done over the last 5-7 years, or even more recently, to deal with performance?
Yeah, there's a lot of great techniques that we've done, that we've engineered. Different types of join algorithms, for example, is one thing. Second thing is that we are very smart about using the capabilities provided by the databases, and as they've gotten with the appliances and other approaches, as they've gotten more and more powerful and more capable, we take advantage of those. We also get some free ride benefits from faster networks, faster CPUs, faster storage. So that kind of comes into play as well. And then I think the flexibility that's been provided by new caching techniques, giving a lot more mix and match, kind of persist a little you know, really works out great. So all those things combined have really just continued to move the envelope in terms of performance.
Okay, good. And you talked about migration. You were talking about data warehouse migration, which is certainly something that's come up in the last couple of years with all the new options now for what you can use to house your data. But here's an interesting question about use cases where an enterprise wants to decouple apps with long-term value from data structures. So I guess they're thinking of some operational type apps. Can you talk about data virtualization as a way to facilitate that kind of migration?
Sure, that's certainly possible. I think the thing you're really thinking about there is, you know, the activities of an application that are the reads and writes to the database. Which of those can we, should we be intercepting and enabling not as direct calls to the original database, but through a layer, and when that makes sense and when that doesn't make sense. Typically, a lot of applications are single row reads and writes. Look up the address, write the shipping transaction. In those cases, I think those are, the direct interaction with the database is the highest performance approach. It's when you've got applications, for example, supply chain management applications where you need to look at a lot of inventory supply and balance it against a lot of demand, or marketing analysis applications where you're looking at information across multiple campaigns and different marketing channels, that that the value of decoupling and adding and providing a lot of flexibility between the apps and the sources just rises exponentially. So the bigger the data sets, the more valuable.
Okay, good. And Rick, I think you have a follow-up to that?
Yes, we've been talking about data virtualization and BI, and now data virtualization and the more operational environment. Bob, can you say something about data virtualization and service-oriented architectures? What role your product can play in that?
Sure. I think, first of all, if you think about the concepts of the service-oriented architecture, the loose coupling principles, the encapsulation, some of those sorts of things, the ability of app servers and messaging buses, and a lot of technology they bring to play, and the kind of that object thinking. Certainly, those objects could be queries that we would perform. So typically, or the database views that then we could query. So I think a lot of times as people, and I think Robin's written about this in the information-oriented architecture in a very articulate fashion, kind of talks to what if we applied a lot of those same traditional SOA transactional principles to data. The logical tool you would use to do that would be a data virtualization server, because we do a lot of that same encapsulation. We do a lot of that. We're architected as a three-tier model. So I think they're very natural complements. And we've seen some companies, for example, Wells Fargo, start on their SOA journey by focusing first on data and not on transactions. So very interesting.
Okay, good. And here's a question on a couple minds out there. Can you talk more about big data? And of course, that's a very big and broadly used term. A lot of times it's talking about machine-generated data, stuff off of RFID chips, for example, or monitors. I know that Composite has a big oil and gas company. But there are all different kinds of big data, and they all have their own sort of unique structures to them. It's not technically unstructured. So what have you guys done to deal with big data? Do you have an array of connectors that deal with the different structures, or how does that work?
Yeah, it's a great question. So there's a couple of ways we think about it. We've shown these diagrams of sources at the bottom and consumers at the top. So one thing we've done is made the big data sources, for example, Hadoop, available as a source so that we could federate a query across a Hadoop store, SAP, a Netezza appliance, and an outside web service. And maybe use that. What is that combination? Well, maybe that's what campaign analysis is. You need to see what some of the clicks on the website and it's stored in big data, but you also need to go out to your outside service provider to see some other aspect, for example, the email campaign programs and the internal impact of those things from some of your transaction systems. So definitely we can visualize or integrate, for example, something like Hadoop as a source. The way we've architected that is to use a Hive in a kind of a HQL or a subset of SQL as the method to do that. So that's one technique. The other thing we do is, let's say you were doing all your analysis in the, you have an appliance, or you have a big data as a Hadoop store. You're analyzing that with a tool above that, and kind of like the data warehouse extension cases. What if some of the data that you need for that analysis isn't in that product? So we can in the Hadoop store. So we can also feed Hadoop kind of as opposed to actually physically moving more data from a different source into Hadoop. We can actually provide a query link so that Composite could be a source to Hadoop and then extend that analysis. So in some ways, if you think about that, we're sitting below the database and providing them some additional information.
Okay, good. And can you talk about security? Because we're talking about accessing all kinds of different data, not through that usual ETL route as Rick was talking about, but rather through this virtualized route. How do you deal with security authentication? Do you use LDAP, or do you leverage the security within the source and target systems? How does all that work?
Yeah, exactly. Security is critical, and what we do is try to leverage as much of the existing security systems as possible. So if all the authentication and authorization is done through LDAP or one of the other different standard tools, then we just integrate and leverage that. The idea is also then there's certain credentialing. For example, let's say one of the sources for SAP. Does the person who's doing the query have access to SAP? Well, we'll check their SAP credential, and that's oftentimes held in LDAP. So authentication, authorization. We can also do encryption, should that be required as the data moves through the network. We have a number of 3-letter government agencies who have us do some of that for them. But the concept is don't add any additional security, just instantiate the security that the user already has.
Okay, good. And we've talked about this before on previous webcasts, but can you speak to a question from one of the attendees here who writes, is it possible to share the same metadata to generate ETL and build the virtualization layer? In other words, he writes, to have the chance to materialize if needed with your existing ETL process. I think he's just talking about sharing the ETL that you have in your metadata, I'm sorry, the metadata in your repository.
Sure. Yeah. Thanks, Ash, for the question.
It's not, it wasn't Ash.
One could, ideally, the query streams that you would write are going to, figure, and the query and the transformations and stuff that you'd write are going to sort out what the consuming app needs. And that's really aimed to the consuming app. Now, if the destination is the schema of a warehouse, then I'm not sure that the ETL, what you'd write in terms of a schema for a view to an app is the exact same schema that's going to be instantiated in a warehouse. If that were the case, then automatically converting your view definition into an ETL script would make sense. The question is, when does the business view definition 100% exactly match the warehouse schema?
Mm-hmm.
And
yep.
I don't know, Rick, what do you've been doing this a long time. Have you ever seen that?
Yeah, my view on the question itself is that I think in the long run, all the data virtualization servers have to be able to support any kind of data integration form. Probably data virtualization will become the default form for integrating data, but if for technical reasons, security reasons, performance reasons, you have to do ETL or maybe even replication, then a sort of a switch should relatively be easy. But I think you have that same view, don't you?
Yeah, and I guess what I would think is if I had a view, and that view, a business view of customer, for example, and then I serve that to Eric through a REST call, and I serve it to you, Rick, through a SOAP call, and I serve it to Robin through JDBC, then viewing a database as somebody else, or a data warehouse as somebody else I serve it to, I would probably just take the existing view, the customer view, and add one more transform to the top to take it so that it's optimized to the schema of the warehouse. Just like I might do one more transform on top to get it perfect for REST, or perfect for SOAP, or perfect for the reporting tool that I'm going through JDBC to get to.
Yeah, and
so I guess I could do it that way.
Yeah, here's another question which I think is kind of speaking to one of the same types of issues here. One of the other attendees writes, data virtualization, particularly in data marts that are downstream from an enterprise data warehouse, would appear to work well for data marts that are read-only. It can be reloaded at will, but how would the underlying data warehouse schema changes be propagated to this virtual layer? I think he's asking a very similar question. In other words, if you make some significant change to your data warehousing schema, is there some way, or sort of an impact analysis type thing that you can do in Composite to see that?
Yes, absolutely. So one of the things we do, and it's a best practice, Mike Linares from Pfizer, when he spoke to the BBBT in January, talked about this at length, is we can run an introspection, and that says, across the different sources, and then evaluating the lineage, and then generate an impact analysis. He runs an introspection every night and comes in the morning every day and says, all right, so did anything change in the sources? It's just simple. It's a batch process. He just runs it every night, comes and sees. He says, in theory, I shouldn't need to do that because I should be in really good conversation with all the owners of the data sources, and they should tell me when they're going to change their schemas. But on occasion, one or two might slip. Sometimes people might forget to tell them, but it's easy enough. Then you just repoint the view or change things a little bit, and it's back up and running, no problem.
Great. Well, folks, we've ripped through a whole bunch of questions here. I hope I got to all of them. Let me throw one more at you, Robert, and I'll push your contact details for anyone who has additional questions, and then Rick, I'll push yours as well. I think you have one. But in terms of all this big data stuff, it's certainly heavy duty in the hype cycle right now. But Bob, from your perspective, how much have you encountered companies using big data like social media or some of these other types? How prevalent is it in terms of rubber meeting road?
Great question. We see it around the edge in terms of customer-related applications first, and I think it's because they're revenue-related. It's in terms of fraud, churn, next best offer, next next offer. Which one is it? I don't want to give somebody the next. I know, but why would I give them the next best offer? I want to give them the best next offer.
Right.
Anyway, sounds like I'm giving them something a little untoward. But anyway, we're seeing a little bit of that, but fundamentally most of the work in big data right now is in silos. And what we think will be the bigger opportunity in data virtualization is one day when people wake up and realize they've proliferated a whole new set of silos and have some real assets there that they want to gain advantage from. But that opportunity is still, that's a consequence. So we like the fact that they're merrily going along proliferating silos right now. Have at it, guys. And then give us a call next year when you decide that you want to look across those different silos.
That's right. Okay, good. Well, folks, we've burned through an hour and 9 minutes here. You can see the upcoming topics. The rest of this month is integration. Of course, March is over half done. We will have one webcast in a week on Attunity, which is another very interesting solution. April is discovery. May, which is sold out, is analytics. We'll have 5 different vendors in the analytics month. It's a very, very hot topic these days. June is intelligence, so more of the traditional BI type stuff we'll be covering then. Governance will probably weave data quality into July. It still is an issue out there. And then August, once again, we're right back to analytics. And folks, you can go to InsideAnalysis.com to stay up on all the other things that we're doing. We also have a show called Federal Spending. You can find information about that there. We'll be talking about education. And of course, we encourage you to hop online and check out all these different issues. And this does conclude our webcast for today. Thank you so much for your time and attention. Feel free to send any questions you may have to me. I'll be happy to answer them. You can also tweet me. You should be able to find me online at @Eric_Kavanagh. That's with a K and no U, the official Irish spelling. So, folks, thank you again so much for your time and attention. And speakers, hang on for a quick debrief. Thanks again, folks. Take care. Bye-bye.